Good afternoon, everyone. Welcome to this course, and it's good to see you all again. We have Asad on the screen. Hello, Asad.
Good afternoon. Good afternoon. How do you do?
Okay, I hope everyone is doing well. Let's just wait for a few more minutes to make sure that all your friends are in here, and then we will begin, okay? So let's wait for 2 more minutes, okay? Okay, I guess we can begin now. Okay, Asad and Maksad, hello. It seems that you guys are very happy seeing each other. Good, and I hope you all are doing well. I would like to request you to turn off your cameras and your microphone as well, because I will need to share the slides on my screen with you. Okay, so let's begin officially. Welcome to EEE 488, Numerical Optimization Techniques and Computer Applications. This is a course, elective course for the 4th year students. And I see that we have Sultan over here. Sultan, hello, do you hear me?
Yes, Professor. Hello.
How are you?
How are you?
I'm good.
I'm fine, thank you. Yes, long time no see.
Yes, sir. I hope everything is okay. Are you still civil engineering or have you switched to ECE?
No. I'm still civil engineer. I just got permission from our head of department
Oh, okay.
Well, the thing is that I finally realized that I do not want to work in industry as a civil engineer. I want to go science for PhD, and this course I think will be very helpful.
Well, I'm
So,
glad you
just
joined,
pure
and we're
interest.
happy to have you here. So I was just surprised. I just wanted to make sure I not mistaken you with someone else. So it is the Sultan from Civil Engineering. No worries.
I'm the one.
Students from any background or any department are always welcome to take this course. Good. Okay, and do we have Ainur, my TA?
Hello, Professor. Yes. Hello,
Okay, hello Ainur. How are you?
Fine.
Everything okay?
Yep.
Okay, great. Okay, good. So I guess I can share my screen now, and then we can begin with, let me see. 1 minute. Okay, can everyone see my screen?
Yes.
Yes.
Okay, good. So as you may have already noticed, I have already uploaded some material on Moodle. And this is the course specification form. That means this is the form in which you will find the details of the course, what are the expectations, how many quizzes, assignments, exams, and how it's going to work, your ebook and all that, okay? So basically, this course is going to be about numerical optimization. This is a course which is normally taught in every undergraduate program. And since I joined, I thought that this course was missing in our department, being an electrical engineer, engineering department in general. Optimization is a tool that you will be using no matter what you do. So many of you are into machine learning. So machine learning basically is just optimization, okay? Other than that, if you're working in communication networks like resource allocation is also machine learning. Or we will look at a number of examples in this course, and you will see that how I'm sorry, not machine learning, optimization. And if you look at a number of examples, we'll see the different disciplines and different areas in which optimization can be applied. This course basically is just to give you an introduction to this topic, because it's an undergraduate course, and normally in master's or PhD there is a more advanced course which gets into more details. But for our in our case, we'll be only looking at the very basic and fundamental techniques in optimization, and we'll be learning that. So in future, if you pursue you pursue master's or PhD, and if you are asked to read a paper and you see some of these terminologies, you shouldn't be surprised, okay? So basically, the topics that we'll be covering are fall under these headings, like the univariate optimization, multivariate optimization, unconstrained and constrained optimization, structured and global optimization. Okay. You can take a look at this on Moodle. This is already available on Moodle. I just wanted to make sure that you all go through it. This is. Okay, so this is a timetable. If you look at it, this is a tentative timetable. It means that it is subject to change depending on how we progress, the speed, and hopefully proper internet and everything goes well, okay? So in the first week, we'll be just, having a very smooth and very simple introduction to optimization. We'll be looking at some very simple definitions so that you get familiar and sort of warm you up for the course. And then we will slowly start looking into univariate optimization, where you have only one variable and you're optimizing only one variable in your optimization problem and the different techniques that exist, and so forth. Your week 7 is the most important thing that you should keep in mind, is where you have your midterm. Okay, and in the slides, I will tell you exactly when your midterm is going to be, the exact date. Okay, so I'm just telling you week 7 is important. So mark it on your calendars. And this this course basically doesn't have a final exam. It instead has final project presentation where eventually after completing all the topics, I'll be giving you a paper, a real research paper, and I will be teaming you up into maybe 2 or 3. You're 22 students, so I think 2 are enough. So a team of 2, you'll be given a paper, you'll have to read it, understand it, and implement it. So you have to try to regenerate the plots in that paper. And you have to present it to me and your classmates, okay, as your final project. So basically, that is how it's going to work, so that you also know, or you actually are exposed to research papers that use optimization. Most of you know how it works with me. You have pop-up quizzes and you have assignments. Well, because everything is not normal this semester, it's online, so probably it won't be pop-up. I will inform you in advance when you'll be having a quiz. So for example, if you're supposed to have a quiz next week, I will tell you like the week before that, okay, next week be prepared, you'll be having a quiz. Okay, how the quiz is going to be and what you're going to do, we'll explain and we'll talk about it later on. One very important thing is attendance. Okay, even though it's an online course, whenever I call for a meeting, I mean like this session, a Zoom session, I want to see everyone attending it. Like for example, today I do not know, like there are 18 people out of 22, so 4 students are missing for today. So attendance has 10% of the grade. So our TA Ainur will kindly be keeping track of your attendance, and also every session is being recorded. Okay, and once it's recorded, I will be uploading it to Moodle. So for those of you who need to look back into the lectures of what was said, you can do that. But attendance is mandatory. Okay, so please inform your friends, those who are not available today. And that's about it. There are 3 reference books, but frankly speaking, these books are, I mean, I've read them, so you do not have to go through that trouble. All you have to do is just study my lecture slides. And if there's anything that I need to share with you or additionally inform you, I will upload it to Moodle if it's an ebook or some lecture slides or anything else, okay? So please read the slides very carefully. You will be loaded with assignments, with tutorials and tutorials and assignments, so be prepared. Your assignments will be programming assignments. So basically you are a 4th-year student, and I expect you guys to know some programming language by now. Python or MATLAB is preferable, but if you want to use any other tool, any other software, you are more than welcome to do that. So that's it. That's everything that I need to tell you. Do you have any questions regarding the course specification? If you have any questions, please ask me now.
Could you explain more about the project, like what we will do?
Yeah, the project is going to be a paper. So I'll be giving you probably a journal paper, which is, I don't know, related to some network, okay? Because optimization makes sense when you have many agents in your system. And you'll have to read that paper. So I will give you the list of papers, okay? And then you guys will have to choose which paper you would like to read and present. And the choices, and it works in a first come first serve manner. So whoever chooses the topic, the paper first will be assigned the paper. So whatever paper you get, you will have to read it and implement it. So there'll be an optimization problem in the paper. You have to implement it in some programming language, Python or MATLAB, and you will have to regenerate the plots that were shown in the paper to help me understand, or let me actually assess you and make sure that you have understood how to actually program an optimization problem. And then you'll have to prepare a presentation, and you'll present it for all your friends as well as me. And then you will be assessed by me and your TA. Is that clear enough?
Yes, thank you.
You're welcome. Any other questions?
Can I ask a question about the project as well? Is it mandatory to have a background in electrical engineering? You mentioned networks. I
mean,
don't
when I
know
say
any of that.
networks, you don't have to know what is TCP/IP, UDP, and all that. You don't have to know all that stuff. Networks means there are a bunch of nodes, and these nodes are connected. It may not be even a network. It may be, I don't know. It's just some nodes, and you want to, for example, distribute some resource, say memory or say vaccines, to some nodes, such that, for example, you want to control the spread of virus. Just giving you an example. Okay. So it's not going to be very technical. It's going to be very general, but I'm sure, definitely sure that you know what it's going to be. Okay, it's not going to be very technical. Don't worry.
Yes, thank you.
Mm-hmm. Any other questions? Okay, good. So we close the score specification, and we now share the slides. Okay, guys, can you see my slides?
Yes.
Yes.
Okay, good. Okay, so today basically we'll be beginning our, and also one more thing, maybe Ainur, when it's time to stop, just tell me to stop. Otherwise, I'll keep talking, and I do not have a clock now. I do not have a watch. So when our time is done, please let me, because I have a class immediately after this class. I mean, we have a class immediately after this class. Okay, thank you. Okay. So the first lecture will be about fundamentals of optimization, obviously. We'll be looking at some basic definitions. But before that, for those of you who do not know me or maybe forgotten who I am, I probably taught you a couple of courses. So this is me, this is my background, and my email address. And if you want to know more, well, this is my research topics that I've been working on for the last maybe 5 years. If you're interested to do research, well, I guess maybe in the 4th year, now that most of you are doing capstone, is too late. But if you're interested to know more about my research, you can always contact me. I can talk, we can have a talk, and you can visit my homepage and you can see what's going on over there, okay? Okay, so this is a tentative deadline. I'm sorry, tentative schedule of what we'll be covering. On the right, you see A1, T1, A2, T2. For now, ignore that, okay? Because I'm not still sure whether I want to give you 10 assignments or 5 assignments, okay? In the very first time when I taught this course, I gave 10 assignments and the students were like overloaded. And one of the comments in the feedback was that too many assignments. Then last semester, when I gave 5 assignments, students, some of them said the assignments were less. We wanted more practice. So depending on how we go, I will decide on how many assignments will be there. So if you guys are good children and don't give me a hard time, I'll probably give you 5 assignments. But if you are naughty and you make me angry, I will give you 10 assignments, okay? So we'll think about that and how the assignments will work. So A stands for assignments and the T stands for tutorial. Tutorials means I will give you some bunch of questions and you probably will have to spend a day or two trying to solve them. And then after that, I'll provide the solutions. So like it's a kind of practice, a recitation, okay? So that it will help you practice and see some sample questions that you could expect for your quiz or exam, all right? So week 1 basically is just introduction to optimization. Then we will begin more formally from week 2 onwards. And as I said, week 7 is the most important week, as you see over here. It is a midterm, and I want you all to mark your calendars right now. 23rd February, 12 p.m. to 1:30 p.m. is going to be your midterm exam, all right? Tuesday. So it's going to be during the class, so you guys do not have an excuse. All right, and I'm the first person probably to set a midterm from now. So if anyone has any overlap or anything, that's your problem, okay? Because I'm sure that you won't be having any class or no exam or anything on this time. So mark your calendars. This is going to be your deadline. I'm sorry, your midterm exam. If there is any issue, I want you guys to speak up now. Does anyone have any problem with this time? Good. So 23rd February from noon to 1:30 p.m. will be your midterm. When we are approaching the midterm, I will explain to you how it's going to be conducted, okay? And then after that, after the midterm, you will be given actually, I mean, maybe in week 8, you will be given the set of papers that you can choose from, and you'll be given enough time to actually start working on your papers and implement it. And in the last week 15, probably not week 16, you will be having your final project presentation, okay? Okay, so if you guys are interested or like you like to read books or you want to know more, these are the 3 books that, excuse me, we would be using in our text in our lecture. So the 3 books are available in your library. I don't know whether they have the what we say electronic version or not, but I know they have the hard copy. But again, you can also probably download it from the internet. But if you look at the slides, my slides, and if you follow the lectures and the homeworks, I don't think you'll be needing them. Obviously, if you do not understand the topic, so I highly recommend you guys to even search, I mean, do a Google on YouTube or even MIT course where there are courses on optimization, numerical optimization. So most of the topics that we cover will be found over there. So look at those videos, try to understand it over there if my lecture or my lectures or slides do not help you much, okay? But I'm trying my best, and I'll make sure that I cover everything, and I make sure that you guys understand everything, so you do not have to look anywhere else. But I'm just telling you, do not just sit and only wait, or if you're in doubt, do not just wait there, but search, do a Google, and you will find several videos on topics that we'll be covering, all right? Well, the lecture hours, we know it's Tuesdays and Thursdays from 12 p.m. to 1:30, and we'll be having tutorial sessions. So some of the lectures we'll be spending on solving tutorial problems. And some of them, if you have any doubts regarding the lectures, we can rectify them and discuss them. So I'm not going to follow a very strict schedule that in week 1 we have to finish this, week 2 we have to finish this. I just want to take it easy with you guys, because as I said, this is not a classroom, and it's even much more difficult for me to try to convey material to you guys, because this is a kind of math-oriented course, and it needs time to understand it. Okay, if there was a whiteboard and I could write for you easily, it would have been much more easier. But I'll try to do my best and to deliver as much as I can, as long as I make sure that everyone is following with the same pace, okay? If you need a consultation, well, I normally, my children wake me up at 7:30 in the morning, but then I'm very sleepy till around 10 a.m. And so if you start emailing me at 10 a.m. till 4 p.m., I probably will respond very quickly. But normally after 4 or 5 or 6, I again get back to my own research. So I do not check my emails, or I rarely check my emails, I can say that. So the best time is between 10 to 4 p.m. So if you have any doubts, any questions, drop me an email and I will respond quickly, okay? If you need to discuss something online, if you have any issues that you need to discuss, because as I said, this 1 year has been difficult for everyone, for many of us, and I am trying to do my best to make it easy for everyone. So if you have any issues, if you need any extra help in terms of understanding a topic, or anything that I or the TA I know can help, please just drop us an email and we'll try to find a solution, okay? Please do not drop me emails regarding, I don't know, I need grade for this, my quiz is like this and this and that, okay? Don't do that, okay? You know that it won't work with me. I probably will not even reply to your email. Attendance is important, 10%, okay? So make sure you attend the online lectures when I call for a Zoom meeting. Unless you have a real medical issue, which with a medical certificate actually confirming that you couldn't attend a particular assessment item like your quiz or exam, it will be graded as 0. So make sure that you attend everything. I'm saying this because like last semester, there were some students, they forgot to even attend their final exam and it was a mess, okay? Not in my course, in some other course. So make sure that you check Moodle or your emails frequently for notifications and announcements, and please attend these lectures as what we say, punctually as you can. And also when we have discussions, I know that I'm the only person talking, but I don't want to be the only person talking. So I expect you guys to be active. And when it comes to a topic that I'm explaining, I want you guys to give me your peace of mind. If there's something that I ask, I want you guys to respond. Okay, this is not just me talking and you guys listening, or probably even just logging in and just going and doing your own business. Okay, so I will call out names while I'm teaching just to make sure no one is sleeping and everyone is following, and I'll ask that person to explain something or give me the answer. And as I said, how active you are in class actually helps me create an impression of how you should be graded in the end. Okay. 5 pop-up quizzes, each of them 4%, which is quite heavy. So make sure you do not miss any of the quizzes. And how the quizzes are going to work, I'll tell you once we have a quiz. So for now, you do not have to worry about that. Normally, you'll have 2 of them before your midterm and 3 of them after your midterm, because the material or the content that follows the midterm is more complicated compared to what will be before the midterm. Okay. So no excuses on your quizzes or absence. So make sure you are ready and make sure that you are present. As I said over here, you can I mentioned that you'll have 10 assignments, 2% each, or you can have 5 assignments, which would be again 4% each. So I'm hoping I'm going for 5 assignments now, but don't make me change my mind later on. Okay. Then, as I said, you will be having tutorials or those recitation sessions, and even problems will be given to you with solutions so that you can solve them and you can practice them. But again, don't only rely on that. You have to always search, Google here, there, look for exercises and try to solve them to practice, okay? The assignments have a deadline, and make sure that you submit your assignments to Moodle before the specified deadline. Over here, I've set to TA because the slide was taken from the very first time I taught this course, where if our TA remembers, I had a box made, and on the box I had written like assignment, and it was in the TA's office. So, but now, unfortunately, we are all at home, so the submission should be on Moodle, but before the deadline, okay? Late submissions obviously will have some deducted grade. So this is the pie chart, and your TA is Ainur. I'm sure most of you know her, if not all. So if there's any issue regarding any issues with your grading or assignments or anything, you can contact her and she will definitely resolve it. Okay, do we have any questions so far?
No. Oh.
Okay, good. Now, what should we expect from this course? Well, first thing you should, and one more thing, guys, another thing. While I'm teaching, please do not chat in the group over here in the chat box, because this will distract everyone. And as I said, this is a recorded session, so please pay attention. And I will be asking questions randomly from any person. If that person doesn't answer, it just sends me a different message. Okay, so please just listen for 1 hour, 15 minutes, and then you can do whatever you want after. Okay. Okay, so what we're going to learn in this course is about optimization. You must have heard this term optimization a lot, but now we are going to see what it actually means, both theoretically and in practice. Okay, so we'll be seeing some real world problems and where it can be applied. And basically the reason why I insisted and I made sure that this course is added to our syllabus is because most students, whoever I look at, they have optimization in their work, okay? Whether it comes to circuit design or whether it comes to, I don't know, FPGA design, where to put the pins and all the stuff. And when it comes to machine learning, basically, and everything, you see there is some optimization, and there is definitely optimize, even communication network. So it's an important thing, and I'm sure that in future it will help you some way or the other. Okay. And another thing that you guys should keep in mind is that if you're taking this course, it's an elective course, so probably you have other options to take. But do not, even though it's online, but do not expect this course to be easy peasy, okay? It will be challenging in the sense it will take time, it will take effort, and you have to invest your time and effort in this course, okay? Do not think that you will get through this course very easily, even though if it's an elective in the end, well, I won't fail anyone, I won't do that. But if you do not get a very high grade, do not ask for more, because probably what you got is more than what you actually deserve, okay? So you know that I will try my best to make sure that everyone learns something. And my exams, you know, my exams, they sometimes are tricky. It's the same for this course. So you will have to study, okay? Do not think that, and of course it will be open book, open internet, whatever you want. And that makes it even more difficult, because then you won't find my questions anywhere, because it will be something that comes to my dream, right? So you will have to work hard to gain or to earn what you really want, okay? So please do not disappoint me. I know you guys, I know most of you, I remember most of you, and I want to keep that good impression. So please do not spoil that for us, okay? Do your best, work hard, study well, and by the end, even if you hate me, I don't care. But I want to make sure that you learn something and you take away something from this course. And maybe in years from now, 5 to 6 years, someday you will remember, oh, that professor over there, he taught me this, okay. 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 Now let's get to the definition of optimization. Okay. So an optimization problem, basically, as a definition, I guess I have I can use a pen. The optimization problem, this is a kind of informal definition for optimization. It means that if you have a problem, what you want to do is, that problem may have many solutions, okay? But given a set of constraints or limits or limitations for that problem, you want to find the best possible solution, okay? So what you want to do is, you have some function, which we normally call the cost or utility function, which is the objective function, okay? What you want to do is, you want to either maximize or minimize this objective function, okay, under the influence of some constraints. Okay, so subject to some constraints. So you have a bunch of constraints. If I remove those constraints, I would have a larger set of solutions, but when I impose some constraints, the set of solutions reduces. Now, from that reduced set of solutions, I want to find the best solution to that problem. And when I say best solution, it means the maximum solution or the minimum solution, okay? So this tells us many things. So an optimization problem has an objective function, which you want to either maximize or minimize, and it has a bunch of constraints. So there are 3 things you should keep in mind. Objective function, okay, which needs to be maximized or minimized. That means you want to find the minimum solution or maximum solution of this objective function under some given constraints. So these 3 things make up an optimization problem. So where are the applications? You have it in data analysis and model fitting. So most of you know what regression is. Do you know what regression is? Did you guys take a course on machine learning or any course with Professor Zolanvari?
Yes, we did.
Okay, so basically you definitely know what regression is.
Yes, we were taught that.
Good. So regression is, you have a bunch of points and you want to fit a line that passes through these points such that the distance between that line and those points is minimum. Okay, so again, it's a minimization problem where you want to minimize the hypothesis value, the difference between the square of the difference between the hypothesis value and the y value from the given line. Okay, so you want to find the best line that fits that bunch of dots on the graph. So that is obviously an application of optimization. Structural design problems. For example, you want to build a structure, it can be, I don't know, some system, it can be a building or whatever. And when you want to design it, you want to optimally use the space so that you can place all the components in that given space, okay? So for example, if you have a circuit and you have a bunch of processors or chips that you want to place on this, you have to find a way to optimally place them, for example, so that the linings, the wirings do not overlap, or the overlap between the wirings is minimized, okay? Then we have resource allocation, which is in wireless, social networks, and everything. I gave you a very simple example. We have a population, and now COVID is something that has destroyed everyone's dreams over the past 1 year. And so now the vaccine has been produced. Well, I don't know how effective, but there is a vaccine now. And now the problem is how to optimally distribute the vaccine within the population so that the spread of the virus can be minimized, okay? It cannot be, eradicated totally, but it can be minimized. So we have to choose those people first and immunize them or vaccinate them so that when they come in contact with other people, so for example, if you have a population and there's a person who is a very famous, or what we call an influencer in the network, that means he is connected to many people, okay? Say he's a celebrity. So if and he's in touch with many people every day, he meets many people, he has to meet many people, he or she. So if you vaccinate that person, then the probability of that person getting spreading the virus would be actually minimized, right? So we have to choose those nodes very intelligently and wisely. So this is known as resource allocation. Computer tomography, you know what CT scan is? It's that device where you sleep and you put your head inside and it scans your body, takes pictures. So actually the CT scan itself, it uses optimization to optimally take pictures and to overlap them from all in a 3D image manner, okay? So these are all applications of where optimization is actually applied. Now, if you want to model an optimization problem, there are 4 steps that you should keep in mind. First, you have to understand the definition of the optimization problem. Without understanding that, there's no way you can come up with a formulation, okay? So first thing you do is define the optimization problem, okay? So someone is talking to you, say, I have this problem, I want to solve it. So in your head, you should be able to write the problem statement, okay? We want to do this, such as we want to maximize this under this constraint. And that's your definition of your optimization problem. And then you have to choose the model parameters. Then based on that, you have to see how you want to solve that problem, whether you want to use linear programming, nonlinear programming, mixed integer programming, convex programming, whatever approach is available, okay? So you should be able to define your parameters, and based on your parameters, you can choose one of the techniques to solve that problem. And then once you find the technique, or you find the procedure to solve that problem, the next step is to actually define the decision variables. These are the variables in your optimization problem that actually should be maximized or minimized. So they are the main variables in your optimization problems, and they are functions of your model parameters, okay? And then after that, once you have your decision variables, then you can easily formulate your problem. You can say, okay, I want to maximize, you get an objective function, which is in terms of your decision variable, and you write the constraints, and that's it. And then you give it to your software, your tool, and it solves it for you, okay? Now, just let's look at how we follow these steps in some examples. This is the first example. The 0-1 knapsack problem. Have you heard of this problem? Anyone?
No.
No one? Anyone?
No.
Marat, have you heard of this?
No.
Really?
No.
See, this is really not good. I mean, you guys are ECE students. You do not know what a 0-1 knapsack problem is. Okay, never mind. Let's deal with it. Okay, so basically this is the definition of a knapsack problem. I'll give you 1 minute, read this, and then I'll explain. Okay, so basically, the best way to understand the 0-1 knapsack problem is assume that there's a thief, okay, and he breaks into an antique shop, and he's having a knapsack. A knapsack is kind of bag like the Santa Claus bag, okay, and he has a knapsack, and the maximum weight that the knapsack can carry or accommodate is W, okay, so that's the maximum weight that the knapsack he can carry in his knapsack, okay. And now in the antique shop, there are n number of items, antique items, and he can choose any of these n items, okay? So let's number the items like the first item is item 1, second item is item 2, until the nth item, okay? So the ith item would have a weight Wi. So each item has a weight, small wi, and it has a value or profit, which is pi. Okay, so depending on what he chooses, it may be gold, silver, bronze, whatever. So it has a weight and it has some value, okay, money value. And these two values and these two variables are assigned for each of the n items, okay? Now, the problem is, what items should the thief pick up and put it in his bag so as to maximize his total profit, the total value, while not exceeding the capacity of his knapsack, while the total weight of those items is not more than capital W. You understand the problem? Now,
Yes.
is there anyone who needs me to repeat this? Everyone okay? Please do not be shy, okay? I want you to speak up. There's nothing to be shy, okay? I mean, if you ask a question, it doesn't mean that there's something wrong. It's you're asking a question, okay? So if there's someone who doesn't understand this, please ask me. So there's a thief, he has a bag, maximum weight is W, he breaks into a shop, he has n items to choose from, each item has a value, PY, and each item has a weight, WI. So he must collect as many items as he can, such that the total weight of all the items is not more than capital W, and he wants to take the most precious item so that when he sells it in the black market, he makes more money, okay? Maximum profit. Now, the reason why it's called 0-1 knapsack problem is because the thief, for each item, it's a discrete item, okay? It's one piece. So he either takes it or he does not take it. It's not that he can take part of the item and say, okay, I want 1/4 of this item and 3/4 of the other item. No. So he either takes the whole item or he does not take it. That's why it's called the 0-1 knapsack problem, all right? There's another version of the knapsack problem, which is called the fractional knapsack problem, where assume that the items are dust. So there is dust, and so he can take portions of each item. Okay, so he can take 1/3 of the item, then 2/3 of the other item in order to maximize his profit. So the 0-1 knapsack problem is a problem. So assume that, God forbid, you guys go into a shop and well, I don't want to say you guys are thief, but let's assume, okay, you want to take the items, okay? And let me say I go into a shop and I want to take some items, okay? So the way I decide on which item to take, how would you do it? What would be your approach? Suppose you have n items and there's a weight and there's a profit. What would you do? How would you choose?
Take the most profitable and leave the most weightful.
Exactly. So you start with the item which is the most profitable. You have a table, okay? So I assume I've been told that, okay, item like item X is the most profitable, then item Y is the next most profitable, and I have this table and the rate is given to me as well. So I begin with the most profitable item, put it in my bag. Does it exceed the weight of the knapsack? Not yet. Then I choose the next most profitable item and I put it in my bag, and I keep doing so until this constraint is not violated, okay? Once it's violated, I stop. Now, the problem with the knapsack problem is that it's known to be a greedy approach, in the sense that I am making a greedy decision. That means at that particular time, I'm being greedy and I'm choosing the most valuable item first, okay? So my decision is based on choosing the item which is most valued first. Now, the knapsack problem does not always guarantee optimal solution. That means, I'm sorry, the 0-1 knapsack problem does not always guarantee optimal solution. That means if I use this approach, this strategy, as I just mentioned, it does not always lead to having the most valuable set of items in my bag, okay? So the 0-1 knapsack problem is, we will be probably briefly talking about it, the greedy and dynamic programming problems. So 0-1 knapsack problem, which I just explained, is a greedy approach to solving the problem, and greedy algorithms do not always guarantee optimal solution, okay? Now, on the other side, the fractional knapsack problem, where you can take portions of each item, is solved using dynamic programming, and it always guarantees optimal solution. So in a fractional knapsack problem, if I use the same technique, I will always get the optimal solution, okay? So this is something that we'll look into details later on, but for now, let's just focus on 0-1 knapsack problem. You know the definition, and you know the strategy on how to choose the items. So as I said, there are...
question.
Yes, sir.
Sorry to interrupt. I was just thinking maybe we can take this kind of approach. We have two variables, weight and profit. Profit is good, weight is kind of cost variable. We have to maximize the former and minimize the latter. So if we'll rank all items by price divided by weight, and take those which have the highest,
ratio?
Proportion? Ratio, yes. Will this kind of approach be better than taking?
Again, it will not lead to the same. Actually, maybe in the next class, I can provide you an example, simple example to prove that this doesn't work. Okay? Let me write this down because I understood what you're saying. 0-1 knapsack example. And I will show you that it doesn't work. Okay?
Thank you.
You're welcome. Now, so how do we define our problem now? We say that we are given a set of items, and each item has a weight and a value, okay? What we want to do is we want to find a subset of such items, okay? Or we want to choose from all these items some subset such that the total weight that we choose is less than or equal to this weight or the capacity of your knapsack, and the total value of all the items is maximized or as large as possible. Okay, so once you know how to define your problem, okay, then it's very easy to find the model parameters. So we have n, as I said, there is a set of items, so we have a total of n items. We have a capital W, which is the maximum capacity of the knapsack. We have WI, which is the weight of the ith item, and we have PI, which is a profit or the value of the ith item. So these are your parameters. Simple, right? Step 3, now we decide on what would be the decision variable. So we have just one decision variable over here, which I define as Xi, and it is 1 or 0, 1 if I select item I, and 0 if I don't. So if I choose item I, then, for example, if I choose item 2, then x of 2 will be equal to 1. If I do not choose item 3, x of 3 will be equal to 0. Since we have n items, so we will have xi's from 1 to n. So we'll have x1, x2, x3 up till xn, okay? Is it clear? So this would be a decision variable. So you have one variable for each item, and this variable tells me whether I pick that item or I do not. So the value is binary. It either takes 0 or 1. Then the next and the last step would be define the objective and constraints, objective function and constraints. So the objective function or the cost function would be summation of xi's times pi's. So I'm saying which items I choose and the price of those items. And I have to sum over all of them, right? So I want to maximize this summation. And the constraints are very obvious. First is the capacity of the knapsack, which is W. So the weight of all these items that I choose, the sum of the weights of all these items that I chose should be less than or equal to W. This is constraint number 1. And constraint number 2 is that the xi's are binary, so they cannot take any other values other than 0 and 1. Okay, so I have two constraints and I have an objective function over here, and that's it. So you are able to solve your 0-1 knapsack problem using this optimization problem. So I have maximize summation I from 1 to n xi times pi subject to summation I from 1 to n xi times wi less than equal to capital W, and xi equal to either 0 or 1 for all I values from 1 to n. And that's it. Okay. Now, this is our first example. So we were able to, so I gave you a definition of the 0-1 knapsack problem. You were able to convert it into an optimization problem. Now let's look at another example. And I want you to go through this and I'll ask one of you to explain it to us. Okay, Tamerlan, can you please tell us what is this problem about?
I'm still reading.
Still reading, okay. Anyone ready?
Well, I can try.
Yes, please.
So in this problem, we have so-called service centers or base stations. I have no idea what that is, but this is something that serves. And we have to install M of such. We have M points where we have to install base stations, and in each of them we can try n different base stations. So M is the number of regions, N is number of BS that can be installed. And for each BS, we have two variables, two parameters, cost of installation and service coverage area. So I think we can think of this problem in this way.
Okay, thank you.
Well, we have. Okay.
Oh, I'm sorry. I'm sorry. Are you?
That's
okay?
Fine. That's fine. I finished.
Oh, okay. Thank you.
You can go on.
Okay, thank you. So the problem basically is about base station, deploying base stations in a given area. Now, what is a base station? A base station are those big antennas that you see probably in your area, and that is where your cellular phones are connected to. So when you use your mobiles or your laptops or Wi-Fi, they're connected to the base station, and the base station is like those long towers, which actually gives you the connection, okay? So what we want to do is, for example, we have 5G now technology, and we want to install the 5G base stations in a given area or a given, say, city. So what we want to do is, okay, each base station, so we have M regions. So if we have, say, the city, and we divide the city into, say, M smaller parts, portions or provinces, and we are given n number of base stations, and they say that you can install a maximum of n base stations only, okay? And M and N need not be the same value. So capital M is a set of all the smaller provinces that the city is divided into, okay? And they need coverage, okay? So you need to be able to cover each of these regions. And capital N is a set of all the base stations, 1 to small n, which is the number of set of base stations that you need to install in the city. Now, when you install a base station, that's good. So you may say, okay, why not just install one base station for every area and that's it, everyone happy? Well, the problem is the base stations are very expensive when you install them. The deployment is not easy. And the government, it has a lot of load on the government or even the tech company to actually install these base stations. So they are not cheap, they are very expensive. So what we want to do is we want to see that how we can minimize the cost of installation, that we minimize the number of base stations, okay, that need to be installed, such that with those base stations, we can cover all these provinces, all these smaller regions, okay? So basically one base station should be able to cover more than one small region, okay? So how do we place these base stations in a particular city such that they cover all these regions, okay? And we want to minimize the number of base stations that we deploy. And another thing, other than expenses, just to add to this, the base stations are not very good in terms of health. So they cause issues with health. So the minimum number of base stations would be more preferable compared to more number of base stations, okay? So basically we have, it's very easy to see that we already have our parameters. We have M, N, and for each base station J, we have a CJ, which is the cost of installing it. And we have SJ, which is the regions that is covered by, so SJ basically is a set, which is it's a subset of these regions 1 to M that is covered by the base station J. So if I place a base station, it should be able to cover one region or more than one region, okay? So this is the definition, is it clear?
Yes.
Okay, so now
Should we
step
assume
one.
that,
Yes, sir.
sorry, should we assume that cost and coverage area are completely independent? CJ and SJ?
CG and SJ, they are independent of each other. Yes, they are independent because the cost, why would the cost and thing be what we say, the set of coverage be the same? They're totally, so each base station has a set of, a subset of regions that it can cover, and it has a cost for installation. The cost may be different depending on where you install or how you install the base station. It can be on top of a building, it can
yes.
be I don't know, on a mountain, it can be just on bare land, so it depends, okay? Because with base stations, it should have what we call, what's that called? Line of, anyone? Line of, I forgot the name.
Site?
Line of sight, LOS, yes. So they should be in direct contact, that there should be no obstruction between two base stations, okay? So it should also, I mean, the way you deploy it, it should be in such a way that they have line of sight, okay? If they are obstructed by a building or something in between them, basically it won't work, okay?
Yes, thank you.
Okay, so you're welcome. Step one is define the problem. So you have a set of regions. So I have a city which I've divided into M smaller regions, and I want to select some base stations, okay, such that the number of base stations that I install is minimum, okay? And they, on the other side, when I install those minimum number of base stations, they actually cover all these smaller regions in the city. Okay, so there should be no single region that is not covered by any one of those subset of base stations that I choose. All right. So again, so these are your parameters, your M, N, C, CJ, and SJ, which we have already seen. And now we define our decision variable. So there will be two decision variables in this case. The first one would be an incidence matrix, or a matrix which is an A M times N. So the dimension is M times N. And each element in this matrix has IJ indexes, subscripts, where each element Aij is either 1 or 0. So it's binary. And it would be 1 if the region I, so I denotes some region in the set M, okay? So if region I belongs to the set Sj, that means region I is covered by base station J, okay? So the J would be from the set M. So the first subscript is I, which belongs to M, and J takes values from the set M. So this element in this matrix would be 1 if the region I is covered by the base station J, okay? And would be 0 if otherwise, all right? So this is one variable. The second decision variable would be again xi, where I denotes whether the base station I is selected or not. Okay, so you'll be having one xi for each of the n base stations. Okay, so this is again binary in nature. So you have two binary, two decision variables. So once you determine your decision variables, all that remains is to define the objective problem, optimization problem. And the optimization problem would have an objective function, which is to minimize the cost of installation of the base stations that you choose. So xi was a decision variable which takes either 0 or 1, depends on whether you choose base station I or not, and the cost corresponding to the installation of that base station. So we want to minimize the sum of all this, okay? And the two constraints that we would have is, one is that every region I, okay, all right, every region, so you're choosing the base station I, okay? And what you want to do is you want to see that at least one of the regions is covered by that base station that you choose, okay? So that means for I from 1 to n, so for all the base stations that you choose, you want to choose Aij was this. That means if region I is covered by the base station J or not, right? So what I want to do is I want to make sure that at the base station that I choose covers at least one of the regions that is mentioned that has to be covered in the city, okay? So the I values that we have over here would be for I belongs to M. That means from 1 to small m, okay? And obviously xi would be either 0 or 1, where I again is from 1 to small n. Now, to understand this better, let's take a look at an example. So let's put some numbers and we'll see how it works. So let's assume that in the city, I divide the city into 10 smaller regions, okay? And I have 5 base stations that I can afford, but I want to see whether I can minimize it and not use all the 5. The regions that each base station covers is given as here. So base station 1 covers the regions 1, 2, and 3, which is defined in M. Base station 2 covers the region 2, 3, 4, 5, 6. Base station 3 covers 4, 5, 7, 8. Base station 4, 9, and 10. And base station 5, 1, 2, 8, 10. Okay? So I know the regions that each of these base stations cover, okay? So this is what this says that, okay, S1, 1, 2, 3 means that the base station number 1 covers regions 1, 2, and 3. Now, so first thing that you do is you should construct the incidence matrix. So as I said, incidence matrix would be dimension m times n, that means 10 times 5. And this is how you construct it. So this is the n's and this is the m, okay? And when you construct that, all you have to do is you already know this constraint, and you have found the decision variable, which is basically the element over here. And that's it. Once you construct that, you just say minimize this, subject to this, and you give it to your software, it will automatically calculate it for you. All right? Now, okay, we will stop over. Okay, let me finish this part and then we will stop on slide 15 for today. So depending on what type of optimization problem you have defined or like the decision variables that you have chosen. For example, today we have seen only binary decision variables, okay, 0, 1s. So depending on, so it can be different. You do not have to only have binary decision variables. You can have mixed integer decision variables. The objective function can be linear, non-linear. So depending on how, what your object or your optimization problem is, it can be classified into different types. So depending on the number of variables, you either have a univariate or a multivariate optimization problem. Depending on how the constraints are, you can have an optimization problem where you only have an objective function with no constraints, okay? Or you can have multiple number of constraints. You can have an optimization problem where you're trying to find the local optimal value or the global optimal value. And this is, for example, you're given a situation where you have information only about a local neighborhood. That means you do not have information of the entire system that you want to work on, but only a local area, and you want to find the best solution within that local area. Okay, so you want to find the best restaurant within 5 kilometers from your current location. Okay, but if you want to find the best restaurant in the whole country, that would be a global optimization. So you should have the information of all the restaurants in the entire country. Okay, so this is local and global. Linearity of the objective function, again, or the constraint. So your objective function can be a linear function or a non-linear function, and the way you approach solving them would be also different. So based on what your objective function and constraints are, you have to decide on which approach you have to take in order to solve that optimization problem. In our case, so far, we only saw linear optimization problem because our objective functions were all linear. Our constraints were linear and it was univariate. Okay, so that's it. So do you have any questions so far?
So at the last example, there would be no solution since there is a row which has all zeros, which means like
There is a
one
what?
region row which has all zeros. Like it means one region is not covered by any base station.
M 1, 2, 3, 4, 5, 6, 7,
Six regions.
6. Why is it 0? Oh, I think I made a mistake somewhere. Wait, 6 covered by, there is a 6. I see 6 is covered over here. There is 6 over here. I think that's a mistake in the typo. You see, there's 6 over here. It's
Okay.
covered by base station 2.
Mhm.
Okay, so base station 2, so this should be 1. Okay,
Mm.
please
Thank you.
correct it. Am I right?
Yes, yes.
Okay. So I guess while I was typing, I made a mistake. It's not even easy to type, matrices in PowerPoint. Okay, so please correct that for me, everyone. Okay, any questions?
No questions. Thank you.
Okay, great. So if there are no questions so far, we will stop at slide 15 and I'll see you guys on Thursday and we will continue from there onwards, okay? And basically, what we can even think of is like probably we can have one lecture every week and I'll upload the slides and you guys study, and the next week we can discuss it or we can quickly go through it so that I make sure that you guys are studying, okay? Because I don't want to spoon feed. I want to make sure you guys are actually studying the lectures and not just relying on my recorded video or me talking, okay? There should be a push. And the push is that I upload the slides, you go through it, you study it, and then when I quickly like just revise it and I explain it to you, and you guys ask me questions. So it should be a two-way communication. We will see how it goes, okay? For now, we will, this week, we will have a lecture again on Thursday, same time, and then we'll see how it goes from next week. Okay, any questions, nothing?
Okay, no
No.
questions.
Thank you guys, take care, and I'll see you on Thursday. You may leave, bye-bye.
Bye-bye.
Thank you.
Goodbye.
See you, bye-bye, bye-bye.
Goodbye.
Professor.